Hi, this is Karthik Rana, and this is the demonstration video for my second project of assignment MEC 4406. In this assignment, I attempted to simulate a robotic soccer game using weebots. This is my second attempt at the project, and while I had made a considerable progress, I also encountered persistent technical challenges, which I'll explain as we go through this video. As you can see in the arena, here is a virtual soccer environment I created. You can see the rectangular stadium filled with proper goal posts at both ends. The soccer ball is placed at the center of the field as required, and the four Pioneer 3DX robots are also visible. Two robots on the left represent one team, and one goalie, and two on the other side represent the same. Each robot has been equipped with a sensor and devices including a GPS, a distance sensor, a camera, a receiver, and an emitter. These components were selected to allow the robots to navigate, track the ball, and potentially communicate with each other or with a supervisor. Now I'll show you the file structure for this project. In this controller directory, you can see several Python files which I wrote attacker key, which contains the behavior logic for the attacker robot's goalie, which contains the logic for the goalie robot's supervisor ball tracker, which is responsible for the tracking the ball's position and sending it to the robots. I also have a folder structure for individual robot controller and test environments. Each of these files were written specifically to support autonomous movement and behavior in the soccer match. Now moving to attacker key. Let's take a look at the attacker file. The script uses the robot GPS to determine its position, then calculates the direction to the ball using the data recovered from the supervisor. This robot then uses a basic steering algorithm to move towards the ball by adjusting the speed of its left and right motors accordingly. The key logic here involves using a 10 to find the angle between the robot and the ball and setting motor velocity based on the angle. The code also includes error handling to ensure the robot doesn't crash if message data is malfunction. Now here's a goalie file which is similar to the attacker code but with important behavioral differences. The goalie is designed to defend its goal by moving when the ball is within the certain proximity along the x-axis. If the ball comes close, it uses its GPS and receive ball position to track the ball laterally and block it. Restricted behavior ensures the goalie doesn't chase the ball across the entire field and instead guards its zone. This is the supervisor controller. Supervisor ball tracker. This script is supposed to run on supervisor node and constantly check the ball position using weebots global get from the function. In this send the ball position to all robots via an emitter or communication channel 1. This idea is to provide the real ball tracking for all robots so they can make decisions based on accurate positional data. Now I'll attempt to run the simulation. As you can see, the robots do move, but unfortunately they do not respond to the ball's position. Instead, they continue moving straight in whatever direction they started. This is because despite having a working supervisor script and properly configured emitter receiver devices, the robot never received the ball's position. After extensive testing, I discovered the root of this issue. Although the code and devices were configured correctly, the supervisor node itself could not be properly inserted into the simulation. Initially, I had used an Atlas humanoid robot as a placeholder and assigned it to the supervisor controller. However, this robot model did not behave like a proper supervisor and the supervisor function did not work. I attempted to insert a standard supervisor node by right-clicking the scene tree and navigating through the insertion menu, but weebots would not allow me to add a robot node or supervisor at the scene root. Even when I selected blank areas or neutral objects, the option remained unavailable. This inability to insert a functioning supervisor node was the critical issue that persisted until the end of my project. In summary, I successfully set up the simulation environment, created the soccer field, configured all the four robots are relevant sensor, and wrote functional control code for the attacker, goalie, and supervisor. However, due to the technical limitation in VBot, specifically the inability to insert proper supervisor node, the robots were never able to receive ball position data and thus could not respond as intended. Despite The overall structure and logic of the system were developed and tested thoroughly. This project gave me hands-on experience with robot control, sensor processing, simulation setup, and debugging within the weebots platform. And thank you for watching this demonstration. While this the finally functionality with limited due to technical constraint, I was able to meet the core planning and development requirements of the assignment. This experience has greatly improved my understanding of simulation-based robotics control system and the importance of properly integrating supervisor node for scene level control.